Welcome to this VLSI Design lecture series. In this lecture video, I'll be discussing about 3 transistor dynamic random access memory. In all our previous lecture videos, we have discussed about single transistor dynamic random access memory. Similarly, we can design a DRAM using 3 transistors, or 3 MOSFETs, which provides better stability. So this is the circuit diagram of a 3 transistor DRAM. If we observe, there are 3 MOSFETs, M1, M2 and M3. These 3 pass transistors are N-channel MOSFETs. If we observe clearly, there are 2 kinds of operations which can be performed: write operation and read operation. In write operation, we will be storing some data inside the DRAM cell. In read operation, we will be retrieving that stored data from the DRAM. There are 2 lines here with respect to write. Write WL, read WL. These are the 2 lines for writing operation as well as for reading operation. Similarly, we have 2 lines which are placed along y-axis, B and B bar, for write and read operations respectively. Here, in addition to these MOSFETs, we have something called as storage capacitor, CS, which stands for storage capacitor. Let us first have a look at how exactly writing operation is performed. So to perform this write operation, we first place the data to be written in the bit line called as write. In this particular bit line called as write, we will be placing the data which has to be written. There are 2 kinds of data, 2 variations or 2 flavors of data as per the digital logic, logic level 0 and logic level high. If we want to store logic level high, so in this particular bit line, we will be storing or we will be passing logic level high. If we want to store logic level 0, in this particular bit line, we will be passing logic level low. So whatever data has to be written, that will be placed in this particular bit line. For example, if we want to write a logic level high, we will be placing logic level high over here. That means we will be pulling up this particular line with respect to VDD. VDD means logic level high. For example, if we want to perform write operation, this write word line will be passed with logic level high. Because the gate input of this particular MOSFET is given with logic level high, which is nothing but VDD in terms of analog terms, whereas here we are discussing about digital terms. So when logic level high is given to the gate input of this N-channel MOSFET, this N-channel MOSFET turns on. That means M1 MOSFET is on. So when N1 MOSFET is on, there is a connection which is possible between source terminal of this M1 to the drain terminal of this M1. It acts as a closed switch. Now suppose we want to write a logic level high, which is nothing but VDD. So this logic level high will be transferred and it will be saved or it will be stored in this particular capacitor. That means logic level high, which is nothing but VDD, will be stored in this storage capacitor. Similarly, if we want to write logic level 0, same way logic level 0 will be placed over here in the bit line, and that logic level 0 will be transferred and it will be present in this particular capacitor, storage capacitor. Next, how exactly this writing operation works with respect to logic level high and logic level 0 is, for logic level high, if it has to be transferred, we will be making sure that this particular bit line is at VDD. To write 0, this bit line will be made ground, or it will be connected to ground or logic level 0. And later we will be enabling this word line. data starts to store in this storage capacitor. For example, if this particular bit line is connected to VDD to write logic level high, the capacitor starts to charge to VDD minus VTH because this particular MOSFET has some amount of threshold voltage. So VDD minus VTH will be the charge which is stored in this voltage which is stored in this particular capacitor. Similarly, if we want to write logic level 0, this particular bit line will be connected to ground. Similarly, the capacitor starts to discharge at that particular point of time, and the storage or the capacitor will not be having any charge which is present in it. So this is how the writing operation is performed in 3-transistor DRAM. Similarly, let us see how read operation is performed. In read operation, whatever value which is stored in this particular capacitor, that will be read out by means of this B bar. This B bar, whatever we have, this bar indicates that we will be getting negated output, inverted output. For example, if we consider that the word line for read operation is high, this particular line is made high. When the gate input of this particular N-channel MOSFET is high, this M2 MOSFET is on. So when M2 MOSFET is on, there is a definite connection established between the source terminal of this M2 MOSFET to the drain terminal of this M2 MOSFET. So it acts as a closed switch. Now, for example, if we consider logic level 1 is stored in this particular capacitor. So because logic level 1 is connected to the gate input of this M3 MOSFET, even that M3 MOSFET is on. So when M3 MOSFET is on, there is a connection established between the source and the drain terminal of this MOSFET. It acts as a closed switch, and this ground will be connected to this B bar. So when ground is connected to any bit line, that bit line becomes equal to 0. So 0 will be stored as B bar. So the logic which we have stored here in the capacitor is 1. The output which we get is inverted output, B bar. We have to remember that. So if we want to read the proper data which is stored in the capacitor, we have to connect this to an inverter later. So this is how read operation is performed. Similarly, if logic level 0 is stored, so when logic level 0 is stored in this particular capacitor, 0 will be connected to this gate input of this M3 MOSFET, and M3 MOSFET is off. So when M3 MOSFET is off, this complete circuit becomes open circuited. So when it becomes open circuited, this logic level 0 won't be present over there because it is not connected to ground. This B bar will always be pre-charged to a value called as 1. Hence that 1 will already be present. So if logic level 0 is stored in the capacitor, the output which we get at B bar and the read operation is 1. If logic level 1 is stored in the capacitor, the output which we get will be 0. Hence, we need an inverter to get the proper output. Hence, we have named here as B bar, inverted output. So this is how write and read operations are performed in 3-transistor dynamic random access memory. I hope that you have understood this video lecture. Thank you.